Hello everyone and welcome to our today's class. It is our second lesson on the topic thermal expansion. So let me start by giving you the quote of the day, which states that for you to get something you never had, you have to do something you never did. To get something you never had, you have to do something you never did. So today we are discussing applications of expansion and contraction in solids. So we'll start with our first application, which is in railway lines. So here is a typical diagram of a railway line, which I've actually drawn here. So you can see that it has some gaps, it has some bolt holes which are fitted with bolts. It also has some fish plates and the rail. Now, how do we apply expansion and contraction in solids? So a railway line applies expansion and contraction in solids in that railway lines are actually always fitted with the gaps. Now the question is, what is the function or the purpose of these gaps? So railway lines are fitted with the gaps to allow room for expansion. Remember, when the temperatures are high, mostly in the afternoon, the rails, because they are made of metallic materials, they usually expand. Now when they expand, imagine a scenario whereby this rail is expanding, this one is also expanding. So assuming there was no gap or space in between any two rails, it means the railway lines will bend upwards, because to expand means to increase in size. So the purpose of this gap is to allow room for expansion, hence preventing bulky bending. So if you are asked to give the purpose of the gaps or why bolts are made in oval shapes in a railway line, so the purpose is to allow room for expansion. So the second application of expansion and contraction in solids involves what we call the steam pipes. So here is actually a diagram of how steam pipes usually look like. So steam from boilers is usually passed through some pipes. So those pipes are usually fitted with what we call the loops, or what we call the expansion joints. Now the question is, what is the purpose of these expansion joints or the loops? So these loops, remember, when the pipes are carrying steam is usually at very high temperature, mostly maybe at 100 degrees Celsius. So at such temperatures, it means the pipes could expand and contract. So steam pipes are usually fitted with loops or expansion joints to allow room for expansion, so that the pipes can actually expand as the steam is passing through them. Remember, steam could also cool. So on cooling, the pipes will have to contract. So if the pipes were not fitted with the loops or the expansion joints, it means when the steam is passing through them, during the pipes will expand and contract. So the forces of expansion and contraction within those pipes will actually cause breaking of the pipes. So if you even look at the pipes of oil transporting companies, they are usually fitted with the loops. Or maybe in industries where steam is being passed maybe from one point to another, the pipes will always be fitted with the loops or expansion joints in this manner. So the purpose is to allow room for expansion, because the force of expansion and contraction could cause the pipes to break if they don't have the expansion loops or the expansion joints. So we also look at another application here of expansion and contraction in solids, which involves the telephone wires or electric wires, whichever. So when electricians are fixing the electric wires, they usually leave them hanging or sagging, or they are fixed loosely in this manner as shown in this diagram. They don't usually fit them very tight. They are usually left sagging or loosely. They are loosely fixed. Now the question is, why should they be left loosely fixed? So this is to allow room for contraction. Remember, in most cases the wires are fitted in the afternoon. That is when the temperatures are high, because the wires have expanded. So assuming they were fixed in a tight manner, like in this case, When the temperatures are low, remember the wires are metallic material, therefore they will contract. So when the temperatures are low, if the wires were fixed tightly, on contraction it means the wire will reduce in size or it shortens, thereby it will be pulling this pole towards this direction and pulling this other pole towards this direction. So those forces due to contraction will cause the poles to either bend or even collapse. So to avoid that, we usually fixed the wires hanging or sagging, or they are loosely fixed. This is to allow room for contraction, So in the morning or during cold weather, this will be the appear end of the wire. So the wires appear to be shorter or taut because they have contracted. When the temperatures are low, the wires contract, thus they appear taut. I will encourage students to try and make this observation. Just look at the electric wires. In the morning when the temperatures are low, you will realize that they appear this way, very taut, or like they are shortened or very straight. But in the afternoon when the temperatures are high, the wires appear to be sagging. They appear to be sagging in this manner, or they appear to be loosely held. This is because in the afternoon when the temperatures are high, the wires expand. So the expansion is what causes them to become longer, because remember we said that to expand means to increase in size. So there is usually a question which is usually asked here, that you can be asked to give a reason why electricians leave wires when they are sagging when fixing those cables or electricity. So the reason is to allow room for contraction, So in the morning or when the weather is cold, this will be the appear end of the wires. They appear shortened because they have contracted due to the low temperatures. In the evening, the wires appear actually to be sagging, or in the afternoon, that is when the temperatures are high, they appear to be sagging because they have expanded. We look at another application of expansion and contraction in solids, which involves steel bridges. So steel bridges simply means these are bridges that have been made from steel. Steel is a metal which can of course expand and contract. So steel bridges are usually fitted with what we call the rollers. These are the rollers. It means this other end of the steel bridge can actually move freely when during expansion and even contraction. So remember, steel is a metallic material, therefore it will always expand and contract with a deviation in temperature. So when the temperatures are high, remember one end is usually fixed, then the other one is free, so that when the temperatures are high, the steel bridges will expand, therefore it just rolls or it moves freely on these rollers. Imagine a scenario whereby this end was fixed and this other end was also fixed. That is, we are imagining that if there were no rollers, when the temperature increases, when this end is fixed and this end is fixed, remember this metal in between this end and this end will expand. When the temperature increases, because it is a metallic material, it will always expand. So when it expands, it means it will require some extra space due to the increased length as a result of expansion. So that increased length, if both ends were fixed, it means our steel bridge will bend upwards, therefore interfering with its efficiency in transportation. So to avoid that, we usually fixed one end with rollers which can freely move, so that to allow room for expansion. So the reason is strictly to allow room for expansion. Then we also look at another application which involves the rivets. So rivets are usually used to fix thick metals, for example in ships, to join them together. So before the rivets is placed into functioning, we usually heat the rivet. You heat the rivet red hot. Remember, the rivet is made of a material which can expand and contract. So in this case, these are the plates that we want to fix. So this is before hammering. So we usually heat the rivet, which of course expands or increases in size. That's why you are seeing there are some spaces between the rivet and actually our plates which have to be fixed. So we usually heat it red hot, then we hammer it flat. So on contraction, that, remember the rivet here was heated. So when we leave it to contract, this will be the appearance of the rivet. So the rivet on contraction, it actually joins these plates tightly, because remember contraction means it is reducing in size. So when this end reduces in size, this end also reduces in size, so the gap between these two ends becomes smaller, therefore they fix or they join the two plates tightly. This is usually applied in a fixing maybe 2 or 3 metals in a application such as in ship. So this will be the appearance before hammering, that is the rivet is heated but it is not hammered. So when it is heated, it is actually large because it has expanded. We only heat the rivet, not the metallic materials. Then after heating, we leave it to cool. So on cooling, it joins or it fixes these plates together because it has contracted. It is the same application that is used in fixing of tires, in metallic tires in railways, in the railway, in railways, actually in railways. So we also look at another application here of expansion and contraction in solids, which involves the bimetallic strip. So here we are going to discuss the working of a thermostat. Now, what is a thermostat? So a thermostat is just a device used to maintain a steady temperature of a room or even a given place. Before the thermostat starts working, we usually connect it to an electric heater. So these terminals are usually connected to an electric heater. So if you observe keenly here, we have a bimetallic strip here, which is consisting of 2 metals, that is brass and iron. Remember from our previous class, we did say that brass expands faster than iron, and it would also contract faster than iron because it has a higher linear expansivity than the iron. Conversely, then the iron will always expand slower and contract slower as compared to brass. So these are typically a bimetallic strip. So we've said that we usually connect the electric heater to the terminals here. Now, how does it maintain a steady temperature of the room? So when the temperatures are high, it means brass will expand. Remember, brass expands faster than iron. So when the temperatures are high, the brass will expand faster than iron, meaning the bimetallic strip will bend upwards. Remember, when brass is expanding faster, it means it will always be on the outer side of the curve. Then iron, because it expands slowest, it means it will be on the inner side. So when the temperatures are high, the brass, the bimetallic strip curves upwards, with the brass outward and the iron inward. When the bimetallic strip curves upwards, when it curves upward, it breaks the contact. Remember, this part is breakable, it is not fixed. So when the bimetallic strip curves upwards due to high temperature, that is, the brass has expanded faster than iron, it breaks the contact. Now when it breaks the contact, remember, this contact is the one that is acting as a switch for the terminals of the electric heater. So when the contact is broken, it means now the circuit of the electric heater is actually open. It is open, or no current is passing through. So when it is disconnected, it means that the electric heater is now disconnected, therefore it does not continue supplying heat. Thus the temperature of the room is lowered. Because there is reduced heat supply. Conversely, when the temperature is low, that is when you want to increase the temperature of the room, or when the temperature of the room is low. Now remember, lower temperatures means involves cooling. High temperatures involves heating or expanding. So when the temperatures are low, it means the brass, the bimetallic strip, which consists of the iron and the brass, will actually contract. Now remember, because brass has a higher linear expansivity, it means it will always contract faster than iron. So because brass will contract faster than iron, it means the brass the bimetallic strip will bend downwards, because the brass will be inward, then the iron will be outward, because the iron contracts lower than brass. So the bimetallic strip bends downwards. So as it bends downwards, it actually moves this contact. It maintains the contact here. Remember, when it moves upward is when it is disconnecting, but when it moves downwards, it maintains this contact. So when the contact is maintained, it means now the circuit of the electric heater is now closed, or it is complete. Therefore the electric current flows through the electric heater. Therefore the heater supplies heat. So you see, when the temperatures are low, the electric heater, the circuit is now complete because of the lower bending of the bimetallic strip. Thus the electric heater is connected. Therefore it supplies heat, maintaining a steady temperature of the room. Now what is the function of the knob? So the function of the knob, which is the knob for setting temperatures, it is used to adjust the temperature at which the electric heater is switched on and off. So for high temperatures, if you want high temperatures, you will set the knob in such a way that you tighten. For high temperatures, you tighten the knob. Remember, this part can be actually tightened. So the knob is adjusted or is tightened in such a way that the strip M moves upwards. Now when strip M is moving upward, it means it is actually maintaining a contact. It means M is now closer to the contact. So the contact is maintained closer to each other due to the movement of M. So it means now that when the temperatures are high, the bimetallic strip bends, curves upwards because brass expands faster. Therefore it means that the temperature of the room has actually to go very high for this contact to be broken. Conversely, when the temperatures are low, we adjust the knob, we release the knob in such a way that M moves downwards. Now when M moves downwards, what this simply means is that the contact here, the distance between the contact here will actually be broken. So it means the temperatures have to go extremely lower for actually the bimetallic strip to bend downwards. That is for the brass to contract faster than iron. For the bimetallic strip has to bend downwards actually to maintain the contact. And remember, when the contact is broken, the electric heater is not actually supplying the heat. So that is how actually a thermostat works. So a thermostat has wide applications. It is applied in fridges, the working of the electric fridges. We also have the adjusting of the temperature of electric ions, the electric ions. So we can also look at our last application here, which is just a bonus, the working of the electric fire alarm. Now how does the electric fire alarm work? So remember, the electric fire alarm also has a bimetallic strip here, which consists of brass and iron. Now remember that brass will always expand faster than iron because it has a larger or a higher linear expansivity. Same case to contraction. So when there is a fire outbreak, remember, when there is a fire outbreak within a room, fire outbreak is accompanied by an increase in temperature. So the temperature of the room will actually increase, meaning the brass will expand faster than iron. So this is our electric bell. So remember, the electric bell, the contact here, we have the contact here, we have the iron, then we have the brass. So when the temperatures are high or when there is a fire outbreak, the brass expands faster than iron, meaning the bimetallic strip curves downwards. It will curve downwards because brass expands faster. Therefore it will want to occupy the maximum space. Therefore it will always be on the outer side. So when the temperatures are high or when there is a fire outbreak, the brass expands faster than iron and the bimetallic strip bends downward. It curves downwards. So when the bimetallic strip curves downwards, it means it is actually making this contact, or it is completing the circuit. So the contact here, this part is connected to the bimetallic strip. Therefore the circuit for the electric bell is complete. So it means now current is flowing through the electric bell, hence the electric bell actually rings. So those are the applications. But we've come to the end of our class. Therefore we will discuss the quote of the day, which actually said that to get something you never had, you have to do something you never done before. You have to do something you never done before. So that simply means that for you to gain anything in life, you must be ready to lose something. For example, to acquire success, there are three things that mostly you have to lose. You will always lose your time, you will always lose your money, and you will always lose your energy. So what does that mean? If you want good results, you must be ready to work for them. You must be ready to sacrifice. Yes, they usually say that no pain, no gain. If you don't incur any pain, then expect no gain. And remember this, insanity is when you continue doing something the same way but expecting different results. So in that regard, I'll give you the costs of success. So one of the costs of success is late nights. So if you want to live a successful life, you must be willing to go through these costs. So one of the costs of success are: 1, late nights; 2, early mornings; 3, very few friends; 4, being misunderstood; 5, feeling overwhelmed; 6, questioning your sanity; then 7, being your own cheerleader. But guess what? Don't give up. It is worth it. Go through those sacrifices and you'll always enjoy in future. Thank you. This is Kind Tuition Academy. Kindly hit that subscription button on YouTube. Thank you.